Good afternoon everyone. Dear students, in our last lecture we discussed the different observations from the experimental study of photoelectric effect. Near about 8 observations we discussed. There may be a theoretical question on that article for a different graph also. So next part we have to study is the different definitions regarding photoelectric effect. These are again very important concepts related with photoelectric effect. There may be a question each for 1 mark. Define threshold frequency, threshold wavelength, stopping potential, work function and so on. So that different physical quantity we have to define here. So see here, the important definitions related with photoelectric effect. What we learned up to last lecture, out of that we have to make some special concepts. We have to write them in proper words. That is the important definition of that concept. So that concepts are: number 1, it is threshold frequency. What is threshold frequency? How we can define threshold frequency? This threshold frequency is defined as the minimum frequency of incident radiation for which the photoelectric effect takes place is called as threshold frequency for given metal surface. We know that for any metal surface, particularly photosensitive, when light of suitable frequency, that word we use, suitable or appropriate. What do you mean by that suitable? That suitable is nothing but frequency called as threshold, at least that is threshold or the limiting appropriate value. Beyond that value photoelectric emission takes place, but before that value, below that value, if light has in frequency below threshold frequency, there is no photoelectric emission. We discussed this using graph also. So this is the definition of threshold frequency. We can define this as the minimum frequency of incident radiation for which photoelectric effect takes place is called as threshold frequency for given metal. We can also define the same definition as the frequency of incident radiation at and below which the photoelectrons are emitted is called as threshold frequency. It is also called as cutoff frequency. So the minimum frequency of incident radiation for which electrons are emitted from the metal surface, means photoelectric effect takes place, is called as threshold frequency for given metal surface. We have seen using that graph. See here, this is x-axis and this is also, that is x-axis, and this was y-axis. On y-axis we take here current, on x-axis we use here frequency. So initially both the quantities are 0. If we go on increasing the frequency, on x-axis there is no photoelectric emission, but as soon as it reaches to a particular value called as threshold frequency, beyond that the photoelectric current increases with increase in frequency. This frequency is called as cutoff, or it is threshold frequency. So this is threshold frequency. So energy for such frequency can be written as capital E. It is equal to H into this nu 0. So this is the minimum energy required to remove the electrons from metal surface. This also we have to give one name that we will study in next part. So this is concept of threshold frequency. So threshold frequency is defined as the minimum frequency of incident radiation for which photoelectric effect takes place that frequency is called as threshold frequency for the given metal surface. So this is the frequency for given metal surface. Next, we have to define the concept of saturation current. See here, what is saturation current? The maximum value of collector current which remains constant even with increase in accelerating potential is called as saturation current. We also discuss the variation of current with respect to potential or intensity. So this is intensity on x-axis and photoelectric current on y-axis. So this is photoelectric current, and this is with constant, what do you kept constant? The maximum value of collector current which remains constant even with increase in accelerating potential. On this axis we have to consider here potential, that is accelerating PD. So this graph is like this. At zero potential, some current flows through the circuit, and beyond this, if we go on increasing the potential, the current increases and it becomes maximum. This value is called as saturation current. So saturation current is defined as the maximum value of collector current which remains constant even with increase in accelerating potential. जरी आपण प्लेटला लावलेलं ॲक्सिलरेटिंग पोटेन्शियल वाढवलं तरी फोटोइलेक्ट्रिक करंट जी किंमत मॅक्सिमम राहते ती वाढत नाही. अशी जी किंमत असते तिला म्हणत असं सॅच्युरेशन करंट. इंटेन्सिटी कॉन्स्टंट ठेवली आणि कलेक्टर रिमेन्स कॉन्स्टंट. मॅक्सिमम व्हॅल्यू ऑफ कलेक्टर करंट विच रिमेन्स कॉन्स्टंट इवन विथ इन्क्रीज इन ॲक्सिलरेटिंग पोटेन्शियल इज कॉल्ड अ सॅच्युरेशन करंट. इंटेन्सिटी कॉन्स्टंट ठेवली आणि फ्रिक्वेन्सी कॉन्स्टंट ठेवली. आपण पोटेन्शियल जर वाढवत नेलं तर सुरुवातीला झिरो पोटेन्शियल असलं तरी काहीतरी करंट आपल्याला मिळतं, त्याच्यानंतर करंट वाढत जातं आणि मॅक्सिमम होऊन ते स्थिर राहतं, त्याला म्हणत असं सॅच्युरेशन करंट. सो दिस इज सॅच्युरेशन करंट, द मॅक्सिमम व्हॅल्यू ऑफ कलेक्टर करंट which becomes maximum and remains constant even if we increase the accelerating potential. So this is saturation current. Next, it is stopping or cutoff potential. This also we discussed many times earlier. So if we go on decreasing the value of negative, that is if we go on increasing the value of negative potential given to collector, it is observed that at some negative value the collector current reduces to zero. This is photoelectric current. This is potential. Here it is zero potential. So if we go on decreasing the negative value of increasing the negative value of potential, it is observed that collector current reduces and finally it becomes zero at a particular value, and that value of collector potential is called as stopping potential. This is stopping potential. It is Vs or V0. This was positive part of that graph with saturation current. If we go on increasing positive, so collector is given negative potential and it is increased gradually. It is observed that at a certain negative value of collector potential, that collector current reduces to zero. So stopping or cutoff potential, the negative value of collector potential for which photo current reduces to zero is called as stopping or cutoff potential. कलेक्टरला निगेटिव्ह दिलं पोटेन्शियल की कलेक्टरची इलेक्ट्रॉनला रिपेल करण्याची क्षमता वाढते. मग हळूहळू त्याला जास्त निगेटिव्ह केलं की त्याची रिपेल करण्याची क्षमता वाढत जाते आणि एका पर्टिक्युलर निगेटिव्ह किमतीला त्याची रिपेल करण्याची क्षमता इतकी होते की ते इलेक्ट्रॉनला आपल्याकडे येऊ देत नाही, म्हणजे करंट काय होईल, झिरो. असं जे पोटेन्शियल असतं जे इलेक्ट्रॉनला स्टॉप करतं म्हणून त्याला नाव पडलं स्टॉपिंग पोटेन्शियल or cutoff potential. So these are the important concepts related with the photoelectric effect. Again, we have to discuss two more definitions related with the photoelectric effect. See here, threshold wavelength and photoelectric work function. These are again important concepts related with the photoelectric effect. So first one is, or we can say fourth one is, it is threshold wavelength. So see here, the maximum wavelength of incident radiation for which electrons are emitted from the metal surface is called as threshold wavelength for given metal surface. Before that, we discuss or we define threshold frequency. Threshold frequency was the minimum frequency of incident radiation for which photoelectrons are emitted from the metal surface. It is represented by nu 0. This is represented by lambda 0. So it is maximum wavelength of incident radiation. Frequency and wavelength are inversely proportional to each other. For minimum frequency, there is maximum wavelength. So the maximum wavelength of incident radiation for which electrons are emitted from metal surface is called as threshold wavelength for the given metal surface. So this is definition of threshold wavelength. So maximum wavelength of incident radiation, or in another words, you can define this as the wavelength of incident radiation at and below which photoelectric emission takes place. एवढी आणि तिच्या खाली फ्रिक्वेन्सीला काय होतं, तेवढी आणि तिच्या वर इमिशन होऊ लागलं, वेव्हलेंथला त्याच्या विरुद्ध होतं, तेवढी आणि तिच्या खाली असेल तर इमिशन होतं. म्हणून ही व्याख्या आपल्याला पुन्हा अशी करता येऊ शकते, द मॅक्सिमम वेव्हलेंथ ऑफ इन्सिडेंट रेडिएशन ॲट अँड बिलो विच फोटोइलेक्ट्रिक इमिशन टेक्स प्लेस इज कॉल्ड ॲज थ्रेशोल्ड वेव्हलेंथ. याच्यावर तुम्हाला 2-2 मार्काचे न्यूमेरिकल प्रश्न असतात, बघा तो फॉर्म्युला कसा करायचा. सो दिस इज स्पीड ऑफ लाईट, c equal to nu 0 into lambda 0, n lambda instead of n, here we use nu 0 and lambda 0. This is threshold frequency, this is threshold wavelength. So how we can write for threshold wavelength? See here, threshold wavelength can be written as c in divided by nu 0. Lambda 0 equal to c means frequency, velocity of light, speed of light radiation in air divided by frequency. So this is threshold wavelength and frequency are related inversely. So this is formula for threshold wavelength. Now see here, next definition, last one, it is photoelectric work function. As earlier we discussed, the frequency required for photoelectric emission is threshold, means it has particular energy with threshold frequency, and that energy is called as photoelectric work function. For any light which is having frequency below threshold frequency, photoelectrons are not emitted, means this is condition part, critical frequency we can say, for which photoelectric emission takes place. And for such photoelectric work function or for such metal surface, the minimum amount of energy required to remove the electrons from metal surface is called as photoelectric work function. So see a definition of photoelectric work function. So this photoelectric work function is defined as the minimum amount of energy required to remove the electrons from metal surface is called as photoelectric work function for that metal. अशी कमीत कमी ऊर्जा की जी ऊर्जा घेऊन फोटॉन त्या मेटल प्लेटवर पडले तर त्याच्यातून इलेक्ट्रॉन बाहेर पडतात, ती जी ऊर्जा असते तिला म्हणायचं फोटोइलेक्ट्रिक वर्क फंक्शन. So minimum amount of energy required to remove the electrons from metal surface is called as photoelectric work function for that metal surface. For metal surface to metal surface, photoelectric work function is different. It is different for potassium, it is different for sodium, it is different for cadmium and so on, magnesium, so on. So these are different for different metal surface, because different metal surface has different structure of atom, electrons, so on, means their energy level. So it is different for different metal surface. So, minimum amount of energy required to remove the electrons from metal surface is called as photoelectric work function. See here, it is represented by phi 0, it is equal to h nu 0. Instead of this part, if we use energy, energy equal to E equal to h nu, but here we define the concept of photoelectric work function. It is represented by phi 0, it is equal to h nu 0 equal to h c by lambda 0, as nu 0 is c by lambda 0. h c, using their values, we get 19.89 into 10 to power of minus 26 divided by lambda 0, it is in joule. This is the work function for any given metal surface for threshold wavelength equal to lambda 0. So, these are the different concepts related with photoelectric effect. So, concepts related with photoelectric effect, we define here the different concepts. Next part, we will conclude the failures of this theory, photoelectric effect, wave theory, to explain the